Great, so this is the worksheet exercise for today. And we have a warm-up exercise with air now that Ryan was talking about earlier. And I thought I'd go through problem number 1 because it is a little bit difficult. It's probably been a while since you've practiced dimensional analysis. So I wanted to explain that and go through problem number 1 with y'all. So basically the scenario, we have a typical diesel generator in Oakland. And this is actually based off of a real project that I did. So I thought it'd be fun to share it. So usually we have a project description. And so it talks about, it's a backup generator. So if a facility ever runs out of power or experiences a shutdown, they need a backup generator. And we have the make, the model year, the brake horsepower of the engine, and the BTU per hour. And then we'll see that the maximum it can operate is 24 hours per day because there's only 24 hours per day. And with diesel backup generators, we usually limit them in the permit to about 50 hours per year. And the fuel consumption of this engine is almost 20 gallons per hour. So here are some abbreviations that are spelled out in case you want to know what NOx stands for or NMHC. These are different pollutants. And so using dimensional analysis, please complete the table below to determine the emissions for the proposed engine application. You may use Microsoft Excel or a calculator to aid in filling out the table. And here are some more conversions. So today I'm going to go through Microsoft Excel to help y'all. And I don't know how much you practiced Microsoft Excel in high school, but I pulled up a Google sheet to help with that. Let's see. Okay. So if you want to follow along, you can also pull up a Google sheet, or you can just watch me answer this table 1. So I'm going to first just copy this table and paste it into my Google sheet. Okay. And so these are the emission factors, and these are based on EPA certified values. And so the EPA is the Environmental Protection Agency of the United States, and it's the federal government environmental agency. So they, for different engines and different models, they have specific emission factors that you can look up on their website. And so these are the emission factors for this particular engine that we're looking at. And so we're going to convert grams per bhp hour to pounds per hour and convert all the way down the table. So to do that, I'm going to start off and put 2.66 grams just to show my work per bhp hour. And I'll just put 1. And so I want to change this to pounds per hour. So I want to cancel out the BHP at the bottom because this doesn't have BHP and it's there. So to determine the BHP, if you remember, it's listed here. So I'm going to take 464 BHP. That's for the 1 engine. And then that cancels out BHP, which is dimensional analysis. So I'm going to strike through it. Oops. And then I need to convert grams to pounds per hour. So that conversion factor is given here. So it's 453.592. Let's see if I can memorize that. 453.592 grams per 1 pound. I'll spell it out. And then so the grams will cancel out. And this is set up kind of like a multiplication. So I didn't explain that. It's kind of like a fraction, but in Excel, I'm going to end up multiplying these factors. So this is how I'm showing my work in Excel. And so I'm left with pounds per hour per engine. And so I'm going to multiply these like 2.66 over 1 times 464 over 1 times 1 over 453.592. So in order to do that as an Excel formula, here in pounds per hour, I'm going to put an equal. Now I'm going to take the 2.66 times 464 over 1 times, and then 1 divided by 453.592. And so that's how I get the pounds per hour in Excel. And the neat thing is if you double click this bottom right corner, it'll automatically populate that same formula for the cells below using B4, B5, B6, and B7, these cells. So the same thing we're going to do across the board. So how do we convert pounds per hour to pounds per day? Well, we know in our example, there's a maximum 24 hours per day that this engine can operate. So we do 2.72 pounds per 1 hour. And we have 24 hours in 1 day, a maximum 24 hours. So we cancel out the hours. And so we have 2.72 times 24. So to make the formula, I put equals, and I'll do this 2.72 cell times 24. And so all of these, you have to multiply 24 to get here. So I'm going to double click this bottom right corner, and it automatically populates the pounds per hour to pounds per day by multiplying it times 24. For pounds per year, we'll have to refer back to our worksheet. So there's actually 50 hours per year. So we're going to take pounds per hour and multiply it times 50 because there's 50 hours in a year. Because this is an emergency engine, it doesn't need to operate 365 days a year, 24/7. It's only for emergency purposes, which is why we have 50 hours. So we have 2.72 pounds per 1 hour times 50 hours over 1 year. And the hours cancel out like before. And so I'll put equals the pounds per hour times 50 hours, which is the pounds per year. And double click the bottom right corner and it populates. And lastly, tons per year. So we have pounds per year and we need to convert it to tons per year. And we know that there are 2,000 pounds in 1 ton. So we have 136.1 pounds per year. And we have 1 ton equals 2,000 pounds. And so the pounds will cancel out when we multiply it. And so it's 136.1 divided by 2,000, or times 1 over 2,000. So it's equals this times 1/2000. And that's how we convert pounds per year to tons per year. And we just double click the bottom right corner. So that is how you answer number 1 using dimensional analysis and Excel. Excel makes it much more faster than a calculator. And from there you can answer the question, did any of the pollutants trigger back or exceed 10 pounds per day? And you look at pounds per day, and did any of these pollutants exceed the number 10 pounds per day? We have 2 here that are greater than 10. So you would put NOx and CO as your answer there. And that is the demonstration for problem number 1.
Thank you, Samantha. That was really, really helpful. And I think at this point, I just want to say thank you to you and Ryan and to Eleanor. And I, for one, am really grateful for all the work you do to keep our air clean.